Yeah, okay. Welcome. So, friends, welcome again to the part 2 of SEM session, which we are continuing 5 minutes back. So, in that session, we were working on logistic regression. We were working on logistic regression on a weather problem. We are predicting weather. We are predicting rainfall in Australia. Okay, so that's what we are doing. So what we have done in the first session is we have explored data, and some primary data exploration has been done, and we have converted some of the categorical columns into one-hot encoding. That's what we did. So now next we were exploring numerical columns. That's what we started with, and now we are doing more exploration on numerical columns. Okay. So the very first step in exploring numerical data is to see the outliers. So for outliers, obviously we do the box plots. Okay. So we specified the figure size. Subplots means in same row. Subplot 2.2, 1 means sub PLT. PLT is matplotlib, right? Matplotlib.py plot. So PLT dot subplot 2.2, row means there will be 2 rows of figures images. There will be 2 rows of images. 2 means again next 2 means 2 columns of images, and 1 means we are right now working on the first image. So first image we are plotting rainfall with the help of box plot. Title you can give, and then second image you are plotting evaporation. Third image we are plotting windfall 9 am, and third image wind speed 9 am. So 2 by 2 means there is a 2 by 2 matrix of images. So total 4 figures we have to specify. We have done for 4 figures. So we got the box plots. So everywhere did these dots. If you, Ashwini madam, I want you to go home today, and I want you to read how to read a box plot. Okay?
Yes, sir, sure.
So you note down how to read a box plot. So I suppose yes, everyone else knows how to read a box plot. So on the above this upper limit, whatever the zeros you have, whatever rings you have, that means they are outliers. So all the variables like rainfall is having heavy outliers, evaporation heavy outliers. Then there are some outliers present in wind speed 9 am and wind speed 3 am also. So you should be able to read like what this middle rectangle of the box plot represent, what this midline represents, what are these two limits represent. And fortunately, these box plots tell us that on lower side there are lower side of values. There are no spectrum. There are lower side of spectrum. There are no outliers. All outliers are on the upper limit, higher side of the lower side. There are no box plots. On lower side there are no outliers. So this is how we read it. Yeah, Ravi sir, you want to add anything?
On a related note, so basically these box plots can be mapped to interquartile range, median, those numbers. So if you are aware of those numbers, then you can visualize that.
Hey, Ravi sir, actually I could have explained it, but in interest of time, because it's a long problem, big problem, I have left for audience to research on their own. So they can go home and just go Google how to read a box plot. Within 5 minutes, they should be able to crack it. Okay.
Correct.
So now next, again 4 plots we are taking. Figure size we are specified 15 by 10, 15 inches width and 10 inch height. Again 2 by 2, 4 figures, 2 rows, 2 columns. First figure rainfall. This time we are specifying number of bins. Number of bins means how many bins we should divide our box plot. So same thing we are doing. You see, these box plots, why we have plotted, sorry. These we first did box plots. Now we are doing histograms. Okay, so we are doing histograms. So we have plotted histograms to see the distribution. So rainfall is concentrated between 0 to 50, 0 to 40 or rather 0 to 40 rainfall. Evaporation, again values between 0 to 17 or 18. Windfall is concentrated below 40, and wind speed 9 am is concentrated below 40, and wind speed 3 pm is concentrated around 40 or little bit beyond 40. So you should know like how to read a histogram. So that again I leave as a homework to all the audience. Just Google how to read the histogram, what is there on the x-axis of a histogram, and what is there on the y-axis of a histogram, and what is the significance of histogram, what is normal distribution, and how to read a histogram. So these two, I think, to read a box plot and to read a histogram is left as a homework. Then we are doing outlier treatment. Okay, we are outlier treatment. So outlier treatment, this is a standard formula. 25 quartile, we first take 25th quartile, then we deduct 3 times of IQR from it, interquartile range. Then we take upper limit, 75th quartile, and we add IQR 3. So between these two, lower fence and below the lower fence and above the upper fence, we are removing all the outliers. Okay, that's what we are doing. That's what we have done here. So what is IQR? What is a quartile? How IQR is used? How IQR is used in the treatment of outliers? That I already shared a document actually with you. I shared a PDF I had shared some time back. So in that all the section, what is percentile, what is a quartile, what is IQR, how IQR is used in treatment of outliers. So I think I will not repeat it, and it's a standard way to treat outliers with these kind of formulas. So these are outliers, and evaporation variable, same formulas have been used, only table name, only column name has changed. Then wind speed 9 am, same outliers treatment. Wind speed 3 am, same outlier treatment, same formulas. So once you learn how to treat outliers with the help of interquartile range, all columns you can treat in the same way. So you have to find it out. Ashwini, especially for you, GESU students, you have to do this homework. Okay, because now I cannot explain it in the class in the interest of time. So now what we are doing, now we are separating, now we are come to the, we are with this above 7 sections. See, there are total 10 or 12 sections. How many? See, there are total, how many sections are there? There are total 11 sections, 12, 13, 14 sections are there, and out of that 7 we have devoted to data exploration, outlier treatment, and this guy has not done missing value treatment. So that is another treatment you have to do. So if you do add that, it will be a very long file. So this guy has not done missing value treatment. Or let us see ahead if he has done. He has done, I think, missing values. He is replaced by medians. So this categorical numerical variables. Okay. Then we are going back to our this we did already. Histograms we saw, outliers we saw. Then now we are separating into X and Y. So what is the capital X? Capital X means our all dependent variables. So take the data frame, drop Y is dropped, rain tomorrow. Y is dropped because rain tomorrow is nothing but our target variable. So except target variable, everything else is dependent variable. Y is our dependent variable, so it is equated to rain drop. Okay. So you see here, note one thing. We have not written here as in place is equal to true. In place is equal to true. We have not written true. We have not written. Why we have not written? Anybody can want to guess?
We don't know because it will. Yeah, we don't want.
Pardon?
We don't want to make change in the original data frame.
Yeah. So if we do this, original data set itself and red tomorrow will be dropped. So we don't want to make this change. That's why we have not mentioned it. So what, without making the change, whatever is the new data set is assigned to X, and then after that, rain tomorrow is assigned to Y. So our DF remains intact. DF has not changed because we didn't do in place is equal to true. Our X is separated, Y is separated. We are splitting into train and trend, test and trend split. We are splitting. So this is standard way of doing. Standard way of doing. Test size is 2 mint. 80% we are taking as trend and 20% we are taking as a test. So you see, we get 4 things out of it. X train, X train, X test. Both X train, X test, Y train and Y test. 4 things we get out of it. And why we specify random state equal to 0? That means if we run second time, our results are repeated. And why results are if we don't specify this, what will happen? What will happen? Anybody wants to make a guess? If we don't specify this, what will happen?
So basically, we are providing a seed to the random state so that every time you run the thing, the same set of rows are being selected.
No. I'm asking you a reverse question. If I don't provide a random state, what will happen?
If we don't provide a random state, right? So the accuracy, every time we run it, we get different precision and accuracy.
Why? Because why? What is the reason? What is the reason behind?
Because the training and the test data would be different in each iteration.
Yeah. So this is a random process. Train test underscore train underscore test underscore split. It selects the row for training and testing randomly. Randomly it selects, right? It selects randomly. So if we don't give this random state, each time different train set will be formed and different test sets will be formed. Each time different rows will be there in the end, train and different rows will be there in the test. So train and test data set will be different each time if you don't specify random state, because it is a random selection of rows is random. So to ensure the repeatability, we just add this particular single line thing. You can make it random set at 0, 100, 1000, 42, whatever number you want, you can take it. So whatever number you want, you can take it, but keep it same in all the runs. So train shape, test shape we are taking, test shape, test there are 28,000 rows, very sizable. Feature engineering. So yeah, so now we are entered into feature engineering, which is the next step. This is also a part of data pre-processing only. This is also data pre-processing. Feature engineering is nothing but data pre-processing. Only difference is whatever we did till now here was on the complete data set. Now we are doing after splitting. Okay. So splitting, how we are doing, let us see. We have again separated categorical. Numerical and categorical have been separated as we did earlier. Then we are checking null in the numerical and null in numerical, train test and train both. See, in train data set, X train, we are checking numerical, how many null columns are there, null rows are there. The same thing we are doing for the test data. Then we are counting, what we are doing is percentage of missing values. Percentage of missing values, numerical variables. So minimum temperature is having 0.0044 as missing value. So we have to see with high values. So I think, see, sunshine. So sunshine is missing null values are 47% are null. Yeah.
Sir, the screen maybe it has shifted towards right. I am seeing some white space only.
Madam, for me it is okay. Anybody else? Are you seeing correct screen? Other guys?
I'm able to see correctly.
And Ravi?
Yeah, I too am able to see the full screen.
I think just some challenge with your end, madam. Either your internet connection has been disconnected and
okay, sir, no problem. No problem.
No problem, na?
You go ahead, sir.
No, then why don't you log in, log out and log in once again?
It is okay, sir. Anyway, I will go through the program later.
Madam, you should do now and now. Now itself, you should understand. That's why we are in the class, right?
No, sir. What I mean to say is that
okay.
is okay, sir. Yeah.
Okay, madam. We'll go ahead. So evaporation around 60% are null. No, sorry, 42% are null, and in sunshine around 47% are null, which is very high. Okay, so we have to see So null values, how he is treating it. So numerical values, null he has listed again. Numerical test also he has listed again. Oh, okay. So he has replaced it above. See, with this code, what he has done with this code, all the null values he has replaced by column median. Same column, it has taken the median value. So I again give one homework to our students. What is the value of what is mean, median, and mode? What is the difference? Mean, median, and mode. Write down. Mean, median, and mode. What is the difference? And when to use mean, when to use median, and when to use mode. Okay. So mode, mean and median, we use for numerical columns. Mean for finding numerical, they describe numerical column, mean and median. And mode is the frequency of occurrence, most frequent occurring. So mode is used for categorical column. So here we have replaced it by fill NA. Fill NA is the method. Fill NA means fill the rows with NN values. That is fill NA. We have replaced with the median of the same column. And why we have not replaced with mean? And why we have replaced with only median? Because mean is always affected by outliers. Mean is always shifted towards outlier. If there is a very big number in data set, you have that column, the mean will be always shifted towards the bigger value. But median is not like that. Median is unaffected by outliers. I'm giving this statement. Mean is unaffected by outliers, and median is unaffected by outliers, and mean is affected by outliers. So you have to find out why. Mean is affected by outliers, and median is not affected by outliers. So I'm not explaining it in the class, very basic. So you should do a little bit of Google search. Why median is getting affected by outliers? Why mean is getting affected by outliers and median is not getting affected by outliers. I'll repeat again. Why mean is getting affected by outliers and median is not getting affected by outliers. So I think you should note it down and find it out why. So here we have taken median replacement, we replaced by median. So instead of mean, I think it is always better to replace by median. So once it has replaced both it is doing two for loops it has used. One for outer for loop, one for loop for train and test, and outer and inner for loop for columns. These two columns and this code, he has replaced all the null values with median, that column median. So now it is checking, there is no null value. Test also no null value. Okay. So now categorical values. So categorical values, mean means it has found out is null mean. He has not done sum. Mean means it will give the fraction. Directly it will give the fraction. Right? So 0.07% of wind. See this one. How to read it? Wind direction 9 am. 0.07% fraction is having null values. A very less null value. So how it is replaced? See. Categorical and I'm not sure is null mean. Okay. So it is doing train, and then for different columns it is finding. It is repeating the same code. See, same. It is same thing is getting repeated actually. So I think this is better piece of code. See, here the results are same. You see, results are same. Only difference is that here location was not having any null, so he has dropped the location column. So he is listing all the columns which are having null values and how much fraction is the null. That's what he is listing with this code. But I think there was no need of this code because only one column was not having no null values. Okay, zero null values. Only location was having zero null values. So anyway, we are able to appreciate and find fraction. So there was no need to write this code again. This big piece of code was not required in my view. Anyway, extra information.
Sir, one doubt here.
Yeah.
Sir, this categorical means these are the string variables. So how is he finding the mean?
Pardon?
Categorical means they will be having this.
Madam, you see here, he is doing mean on is null. Is null is number he is counting. We used to do sum, right?
Yes. Yeah,
So
yeah,
on
yes,
is
number,
null he is
number.
doing mean, na?
Okay. He's just printing. I thought he's replacing it. Fine, sir.
No. See, he is doing that column will come from the for loop column name will come.
Yes, sir.
This
got it.
is null command will find how many nulls are there. Number will come. So on that number, it has found the mean value.
Yeah.
Even if it is a categorical value, this mean is this mean is on frequency, not on the categorical column.
Yeah.
It is on frequency,
Yes.
right? So if mean is greater than 0, then he is listing list only those columns which are having null values. Okay. So impute with the most frequent value. See, I told you now he is imputing categorical variables with most frequent values. Most frequency means mode. So for he's taking first top for loop he is putting. One the for loop will run for trend data and other time it will run for test data. So suppose it is running for the first turn, it is running for trend data. What it will do? It will take these 4 columns, 1, 2, 3, 4 columns, right? It is more taking mode and replacing it with mode. Fill NA method it is using. Fill NA method will take the mode from here. It will take mode from here and it will replace it. And in place equal to true means it will change the directly. It will make a change directly in the either trend data or test data. Directly it will change. Understood, na? Malini madam understood? Shruti madam?
Yes, sir.
Yes, sir.
Ashwini understood?
Yes, sir.
Yeah, Ravi. Ravi, tell me.
One thing I wanted to everyone to notice is that basically he could have done this fill NA before splitting the data into test and train data. He can do that, right? But one question that we need to think about is why did he not do that? But rather, after splitting the data into training and testing data, he did insert the null values with the mean. And if you look at the code, it clearly says that it is the mean of the test training data, not the test data. Even for the test data also, he's replacing with the training data mean or mode. For categorical values, it is mode. For numerical values, it is median.
Yeah, that means we don't want to know our train data. Train data is always unknown. Okay, train data is always unknown. So in the train data also, if you have to replace the null values, we'll replace with the mean of train data. Test data also, we are replacing null values with train data only. So thanks for adding that, Ravi. So this is a usual practice, like whenever we do standardization or we do outlier treatment and all that. For test also, imputation we will use trend values only. Imputation in test data also, for imputation in test data, we always use the values from trend data set only. Okay, so this is a standard practice. So that's what it is done. Then again it is taking categorical. Sum is null, again repeat. Then missing values in X test. So full X test is testing, no null values. Full X train it is tested, no null values. So null value treatment is over. Okay. Then some engineering of outliers. So what engineering it is doing? See, max value and see. Now what this code is doing? This code is replacing, taking the rainfall column and rainfall column, and if value is greater than 3.2, if value is greater than 3.2, it is replacing with 3.2, and if value is less than 3.2, it is remaining the value as it is. Listen, if in rainfall, if value is greater than 3.2, it will replace it by 3.2. Any value greater than 3.2 replaced by 3.2, and any value less than 3.2 is not touched. It is left as it is. Same thing has been done for evaporation, wind, this thing, and the wind speed 3 pm. So little bit you need to study. He has made first one function for it, and with the for loop he has applied it in. It is called capping, upper capping. So it is outlier kind of outlier treatment. So wind speed at 3 pm is capped at 57, wind speed at 9 am is capped at 55, and evaporation is capped at 21.8. So you will ask me how we have decided 21.8, 55 and 55. 57 for the different than 3.2. From where? From air we have brought these values, right? They are the origin from nowhere. So these values are decided by business experts. Our weather scientists told us that it is okay to cap rainfall at 3.2 inches and evaporation at 21 inches should be capped. Wind speed at 9 am should be capped at 55, must be kilometers per hour or miles per hour. Wind speed at 3 p.m. should be capped at 57. So these values are coming from 55, 57, 21.8 and 3.2. These values will come from our business expert. In this case, who is the business expert? Our weather scientist. And we are data scientists who is doing this analysis. Okay. Then see max rainfall. Max rainfall, it is finding the max value. Both are 3.2. Why it is 3.2? Because we have kept it at 3. We have made it at 3.2. So same thing is tested for all. Then describe. Describe is nothing but a command. You should know this describe command. It will give you all numerical data, numerical columns it is taken, train and test numerical columns. And describe what it will give, basic statistics, basic descriptive statistics. So I think one more homework, I think our students should note down. What is descriptive statistics? And what are the components of descriptive statistics? I have given it in the which document which I shared. I will share once again today, PDF, that contains what is descriptive, what is prescriptive, what is inferential statistics. All these questions are there, answers are there. So I'll share once again. Okay. So what is that count? It will say simple things. What is the count of values? What is the mean? What is the standard deviation? What is minimum? What is the value of 25 percentile? What is value of 50 percentile? What is value of 75 percentile? What is the value of maximum value? So this basic single command, all the numerical columns are listed. Very powerful. Encode categorical variables. So all that Ramayana which we did up, again the same Ramayana is repeating here. Converting into one-hot variables. See, all these columns are one-hot these columns. We already converted into one-hot and putting it on the top. I think at that time it was not required to do there. We could have done one time here itself. One time here itself we could have done, but he has done 2 times. He wants to, I don't know why he has done on the top, because one-hot code encoding.
He has not modified the original data frame. He just wanted to show what would happen if I do an encoding for those particular column. It's just an output.
Not required, na, Ravi sir. Ravi sir, if you do it once upon a time, if you do on train data, it will be good, na? Why you want to do on original data set also?
Yeah.
Unnecessary work, right? Unnecessary work. Anyway, so all this categorically is listed, and then it has converted into the one-hot variable. One-hot encoding is all one-hot encoding is done. At the end, he has concatenated everything. So at this stage, all the columns, like all the categorical columns, have been converted into one-hot encoding, one-hot encoded numerical columns. Listen again, all the categorical columns have been converted into one-hot encoded numerical columns. So this has already been given to you as an exercise to know what is one-hot encoding. Okay, so you see now extend.head, all are numerical now, all are numerical. All are these one-hot encoded columns. So 0, 0, 0, 1 will be there in one-hot encoding. Okay. So similar Ramayana he has done for test data also. So all the tests we get one-hot encoding thing, one-hot encoding, all zeros and one converters. So why we convert categorical column into one-hot encoded numerical columns? Because almost all our scikit-learn algorithms need data in numerical format. They cannot understand categorical format. So all data which we give to any algorithm, almost any algorithm, should be in one-hot encoded format. So feature scaling. So scaling means what? See, scaling means if you see trend data set. Trend data set, so this is in 30, 22. Now rainfall is in 0.22. Scale is different, no? Evaporation scale is different. Scale of each data is different. So here, if you see, values are in 50s, humidity and all. Here, if you see, values are in 1, 2s and 0.2, right? Scale is different. So our I explained in as I explained in our linear regression in linear regression, while explaining scaling, why we do scaling, to bring all the variables into same scale. So here, what we are doing min-max scaling. We are doing min-max scaling. What this scaler will do? This scaler will bring all the variables between 0 and 1. Minimum value will be 0 and maximum value will be 1. Proportionately, their transformation will be done. So you have to see transformation. So you see how we do fit transform. So in train data, we do fit transform. Remember this, fit transform, train data. So we do fit, we'll do fit as well as transform in the same method on train data. But test data, we do only transform. We never do fit on test data, which is same as Ravi told in the last time, that any transformation when we do on test data, we take value from train data only. So in fit, when we do fit, it learns the necessary scale to, it learns the necessary formula to do the fitment. And when we do the fitting. So this formula is learned only in the train data.
So one more point to add it is, so basically different models use different functions to create the model. So whenever you see a particular word called fit, that means the model is getting trained.
Yeah, Ravi, we'll come to it ahead. We'll see it when we come to it. Huh?
Yeah, correct, sir. I just wanted to highlight that thing.
Yeah, sure,
when you use dot fit, it means that the model is being learned, is learning the data from the data. If you don't see just fit, but if you see some transformation, then it's just
so what we see here is to do the min-max transformation, some formula is required, some scale transformation formula is required. So we learn this formula during the fitting, and while transformation we apply the formula. So that formula we always learn on the trained data set, and then we apply it on the test data set. So then data set is listed. So now you see same trained data set is described. So minimum values are minimum values are all 0. You see all minimum values are 0 and all maximum values are 1. So it has transformation is done. Then model training. Model training is done. So logistic, same thing. Scikit-learn. You have to import the model. Once the model is imported, you have to specify the solver. I think this is not required for beginners. For beginners, even if they take default solver, it is okay. Random stat for repeatability for the same reason I explained above. Then we are doing fit. Fit means we are training the model here. So while fit, you have to pass both dependent variable as well as label. Dependent variable is xtrain and label is ytrain. Both you have to pass for the training. Okay, so once you do this, it will describe the training has been done after some time. Then prediction. Prediction is very simple. You have a model here now. Model will be stored in log-reg variable. Once your training is done, model will be stored here. Log-reg will be your model. Take log-reg, call predict method on that, and do that predictions on test data. So once you have done predictions on test data, you have your predictions. So test data we are using as unknown. Then what we are doing in the next. So if you use this method, predict method, it will give you yes, no. I explained you that logistic regression usually gives us probabilities. Below 0.5 we call 0 and above 0.5 we call 1. So this method dot predict method will directly give you yes or no. You need not do below 0 do below 0.5 do 0 and below 0.5 probability do 1. You need not do that. It does internally and gives you yes, no. But if you want to know probabilities, so this is the code to get the probabilities. Predict probability, same model, log-reg, predict probabilities. So wherever there is yes, you see the values are either 0.91, 0.83, 0.82, 0.91, 0.79. So this 0.3, wherever 0.3 probability is there, it is taken as 0. It is taken as no in this method. No means probability is below 0.5. Okay, so there are two methods. One directly gives you yes, no, which is good for a layman. But sometimes data scientists want probability also. So probability is given by this method, predict probability. Predict probability, probability you got. Test data also you can get same thing. Accuracy score. So accuracy score, simple method. You have to first import from sklearn matrix, you have to import accuracy score. And this is common across the matrix, like in logistic regression, any kind of classification problem, same accuracy score will be used. Any kind of, whether it is random forest classification, or it is XGBoost classification, or it is neural network classification, the same method will be called. And what input it takes? It takes two things, test and predicted. So y test, actually we know that these are the actual values and these are our predicted values. So we are comparing them to find out our accuracy. So we are finding that 85% of our values, predicted values, are matching with y test. Means our accuracy is 85%. Okay. So then same accuracy we have calculated on see, once here we have below, you see it is done on test data. This is done on test data. In the top row we are doing is for train data. So both you see train accuracy is 0.84, test accuracy is 0.85. So both are very close. That means overfitting is not happening. What I explained in the last class, overfitting happens only when train test accuracy is beyond 5% of train accuracy. So train accuracy is right now 84%. And suppose we are getting test accuracy as at 70% only. So that is beyond 5%. So that means overfitting is happening. Train accuracy is 0.84 and we are getting our test accuracy as 80%. So that is within 4% only. Within 4%. So within 5% means we assume that accuracy overfitting is not happening. So it is very close here. See, in fact, test accuracy is unfortunately more than train accuracy. So no overfitting is happening. Okay. So we have commentary here also. So I'll share this file anyway with you. So all commentary is given. So then we have something called regularization here. Regularization. If any time overfitting happens, we apply regularization. Regularization is Reeds and Lasso. Reeds regression and Lasso regression. I have not covered it in the class so far. So I giving a homework. Please write down. What is overfitting? Number one. Write down what is overfitting. Number one. Number two. What is regularization? Number two. Number three. What is Reeds regression? RIDZ. I will write it here. Reeds or Reeds, I think. Whatever it is. Reeds or Reeds. Wait.
Sir, RIDGE.
RIDGE, na? RIDGE, Reeds, and another is Lasso. So Lasso regression and list regression, you should find out what is it. So what is Reeds? What is Lasso? What is regularization? What is overfitting? And one more thing you should find out is what is bias and variance trade-off. What is bias? What is variance? And what is bias variance trade-off? What is bias? What is variance? And what is bias variance trade-off? So these two things are related with your regularization. So I am not covering it in the class. So you have to take it as a homework, everyone. Okay. So now here we are applied a bit of regularization. So why we are applying? That you will understand when you will read what is regularization. So when we take C equal to 100 or a higher value, that means we are applying lower regularization, very low regularization we are applying. And if we are taking lower values, that means we are applying very high regularization. If I take C is equal to, if I take C is equal to 0.01, that means higher regularization. If I say C equal to 0.001, means even higher regularization. Okay. So like that we take. So right now we are giving C is equal to 100. C is equal to 100 means very low regularization we are taking. And with low regularization, with C is equal to 100, again we have found out train test accuracy, no overfitting. Then this time we are giving high regularization. See, just testing. This is just testing. We are just finding out multiple models. So this time we have increased the value of, we have increased the regularization by giving lower value of C. So this time also train test, no problem. So there is no need of regularization in this particular model, because for this particular data set, Giving regularization C is not required. Whatever default we are giving is enough because we have given 100 also same results and 0.01 also same result. So it is not affecting it. So no need of regularization. Then null accuracy. I will leave it for the moment. I want you to find out what is null accuracy. What is null accuracy? And why we compare with null accuracy. So null accuracy means no model and we are comparing with null accuracy. So null accuracy is 0.77 and our model accuracy is 0.85. So we are doing better than null accuracy. So now note one more thing as not null accuracy. What is null accuracy and why we compare with null accuracy? Because I'm going a little fast on this because there are so many things left right now and they are more important than these things. So right now we have done the modeling. Now what we'll do, we'll come to the important part, which is nothing but confusion matrix. So I feel this is more important than null accuracy and all. So that's why I'm jumping to null accuracy, confusion matrix. Take null accuracy as a homework. Okay. So null accuracy. What is confusion matrix? So from sklearn matrix, import null confusion matrix. So need not do anything. Just say CM is equal to is a method in that. You have imported null confusion matrix. We are calling this method. We have to pass X, Y test and Y prediction test. In testing, we are passing the ground truth as Y test and our predictions we are passing on the test data. See, for any kind of classification problem, whether it is a logistic regression, whether it is random forest regression, whether it is XGBoost regression, or whether it is neural network regression, confusion matrix will not change. Same method you have to import. Same Y test actually you have to pass and Y test predicted you have to pass. Same thing you have to pass. Now, how to extract true positive, true negative? Very simple. Just this is a 2 by 2 matrix, right? Because it's a binary problem. So binary problem, confusion matrix will be 2 by 2. If it is a three class problem, confusion matrix will be 3 by 3. So right now binary 2 by 2. So we are just addressing hard coding. We are addressing true positive, true negative, false positive, and false negative. We are addressing by simple different cells of the array. It is an array, right? So from array we are extracting. So this is the confusion matrix. See, 0, 0 means 20,000. 20,000s are true positive. Then 1, 1. 1, 1 means 1 and 1. 1 and 1 means 32,000. 3,000. This one. 1, 1 means it is true negative. Then you have 0, 1. 0, 1 means this one. 0, 1 means you have false positive. And this one. Then this is 1, 0. This is false negative. Like that we are extracting. Confusion matrix is drawn. All the values are in front of you. Now what you have to do? Anybody wants to guess what after this what we will do?
Precision and recall.
Yes, exactly. You have formulas for that also. Once you have a confusion matrix, you can derive any matrix. So see, now it is confusion matrix. We have converted into data frame. Why we have converted into data frame? Because we want to see the heat map. So heat map, it is nicely, we are seeing into a heat map. Why we are seeing it like this? Because it looks nice. It looks nice. Same thing. But otherwise, confusion matrix in this form also you are okay with that. This is also a confusion matrix. But this looks much better. This looks much better. So a layman, if you want to show this, you will not show this kind of highlighted one. You will not show this. Layman, you want to show confusion matrix, you will show this one. You nicely convert it into heat map and show it. Classification report. So classification report, there is some very detailed report on. Classification report also takes Y test and Y prediction test. Means Y test here is ground truth, your actual values, and predicted value on test. Same thing which confusion matrix also, see it is same. Confusion matrix also same parameters, Y test and Y predicted test. So classification report also Y test and Y prediction test. So now lot of data has come. You see, very difficult to read it. It is not straightforward. If I ask you to read it, you will not be able to read what is classification report. It is another topic of discussion. So unfortunately, I had to give this also this to you as a homework. Note down the question. How to read the classification report of sklearn metric. How to read the classification report of sklearn, scikit-learn. How to read, I'm repeating the question for homework. How to read the classification report of scikit-learn. This is the question. How to read the classification report of scikit-learn. So once you know how to read it, I think it will make some sense to you. So a lot of sense it makes actually. See, a lot of things are there: precision, recall, F1 score, support, accuracy, macro average, weighted average. A lot of things are there. So it is not possible for me to cover it in this class. But if you are not understood, next class we can take it up, because it is very important for neural network and deep learning also. This classification report will be required. So you should know how to read it and what everything of it means. How to read it completely. You should know it. Because in neural network also same thing will be there. If it is not understood, we'll take it up in the next class. Classification accuracy, you have the formula. Just put, you have true, positive, everything. Just put in this formula, get accuracy. Accuracy 85%. Then prediction error, then you classification error. Then classification error, again you have formula, put it. Precision. Precision is, again you have formula, put it, get precision is 94%, which is very good. Recall. Recall is, again you have formula, put recall. True positive rate, you have formula, put recall. Then you have false positive rate, sensitivity, specificity, F1 score. So once you have precision recall, you can find out F1 score. Okay. Then what is this? Print the first 10 probabilities, threshold level. Yeah. So now it is teaching you, first of all, it is listing the probabilities. Probabilities, why we got, why prediction probabilities, what we got now previously is listing it. And is fixing a threshold. What threshold? Store the probabilities in a data frame. So it is nice to see here. Actually, probability of rain tomorrow 0. 0 means class 0 probability and 1. See, 0 day, like today. Today, what is the probability of rain? Rain is 91% probability of rain equal to no rain. And only 0.08% probability of rain. So what this, just have a look at this code. It has converted yes and no probability into a data frame. So this sum will always be equal to 1. Because 1 represents yes and 1 represents yes, 0 represents no. So sum will be equal to 1. Sum will be equal to 1. If you add up anything. Any two values you add up, it will be 1. Right? So if 1 is P, if positive probability is P, then our negative will be 1 minus P, right? So that's what it is. Very simple. Then what it has done, probability of rain, I think. Yeah, so it has put a histogram and plot histogram of predicted probabilities. I think nothing significant. You can have a look. Only histogram is plotted. Then lower the threshold. Okay. So what it is doing is that first he has set threshold at 0.5 and then plotted yes, no. Then he has lowered the threshold. Then he is lowering the threshold to lowering this same confusion matrix is printed, and then it is lowering the threshold. So which piece of code it is showing lowering the threshold? See here, I by 10. So it is taking I equal to 1 to 5, and then it is doing binarize 1 by 10. Then y predict where see. It is setting the threshold in predicted values, I by 10. Binarize it is doing this method. So if y, then converting this y predicted into yes and no. So this step is important. This step is important. So binarize means you have to see what this method does. So why I suppose, I think we have to check it actually what it does. So I think I will, or we want to check it.
Sir, I think binarize kind of like makes it binary depending on whatever the value is, and where it is I by 10, is that what it does?
No.
Binary?
No. Below I by 10, it will make it 0, and above I by 10, it will make it 1. Like that it is. Understand, no? So it is taking threshold 5 times. One is 1 means 1 by 10, 1.01. So is varying threshold from 0.01 to 0.1 from 1 by 10 means 0.1, right? And 5 by 10 means 0.5. So he is taking 5 values of threshold. Threshold of cutoff is varying from 1 to 0.1 to 0.5. 0.5 is standard. We know that 0.5 is standard. So below 0.5 everything is 0, and above 0.5 everything 1. Like that we do. But here he is varying. That means 1 time 0.01. So below 0.01, sorry, below 0.1 everything will be 0, and above 0.1 everything will be 1. Next time 2. Below 0.2 everything will be 0, and above 0.2 everything will be 1. Next 0.3. Below 0.3 everything will be 0, above 0.3 and everything above it will be 1. 0.4. Below 0.4 it will be 0, and 0.4 and above everything will be 1. Like that this binarizes. 4 times each trend he is doing it, and same thing. See, then same thing he has done it.
I think instead of doing 1 by 1, he just put it in a for loop.
Yeah, in a 1 by. So you can do it 1 by 1 also. If you are worried about this for loop and all, 1 by 1 also you can do. So you have to do it 5 times. So then see the confusion matrix with 0.1 threshold. Confusion matrix is this. It has calculated the value. Next, with 0.2 threshold, confusion matrix. Confusion matrix will be different, no? Confusion value will be different if you vary the cutoff with 0.3, with 0.4, and like that he has done. And lastly, it is customary to find ROC AUC, because it is a kind of universal measure for classification, any kind of classification, whether it is XGBoost or neural network or any class of classification. You always plot ROC because it tells you how much your model is good or not. So to plot ROC AUC, use this code and standard code, extended code. So there is no point I explaining this code. Actually, you should be able to see ROC AUC curve is first imported ROC AUC curve. Y test, Y predicted is passed, and positive level, yes, it is done, and then just given the figure size and title and all. So it is your ROC diagram. So your minimum model, that dotted line is your bare minimum model, like bare medium, 0.5, bare minimum. But your model is this blue line, blue curve is your model. So your ROC AUC is how much it is plotting. Value it is not given. Value, oh, you should have given value also, no? Yes, plotted ROC AUC curve, but he should give number also, no? How much number is, whether it is 0.8, 0.6, 0.7. So that number also you can find out. This curve he has plotted, good, well and good. We want this curve to see how good our model is. But we want value also, no? So yeah, ROC, this compute ROC AUC. So we have to first import ROC AUC score, give test and prediction, and score. So the ROC AUC score is 0.87, which is good. Comments, okay? So ROC AUC, then again same, then K4 cross validation. Why he has repeated K4 cross validation? Why? Can anybody tell me? If anybody has any idea, why we did K4 cross validation here? Why we
So basically, he is trying to run the code again, iterating 5 times and just comparing the score for.
Yeah, exactly. So what happens? Madam, we are statisticians. So data science should be data scientists are called statistics guy also, right? So some business guy may doubt कि भैया, one time you run the model, तुक्का लग गया. It is by luck that you got this kind of values. I don't believe your model. One time anybody can guess this kind of. So run multiple time and show me. I want the average value of all the accuracy scores. I don't believe in one single accuracy score, because it can come by chance also. Like that anybody will tell. So you do, yes boss, now I am running 5 times. These are 5 accuracy scores, and to give it to you, I will not give you the highest, I will give average of these 5 values. So this cross validation score it will run our logistic regression model with same X train, Y train 5 times. So this is your cross validation accuracy in train model. It is in train model. It is training accuracy, because we are passing train and both train data we are passing. So this is during the time of training. So give average of it. Okay, give average of it. So average is 0.84 and Y maximum value was 0.85. So you can say, yes, boss, my analysis is very accurate because maximum value is 0.5 and average is 0.84. What else you want? So then he cannot tell you anything. Then hyperparameter optimization using grid search. Another thing he has taken. So here are 2 things I told you. Regularization is of reads. Reads I told. Reads is L1 regularization. So note down one more question. What is L1 regularization and what is L2 regularization? So L1 regularization is same as reads and L2 regularization is same as lasso. Okay. So just note down what it did and why it is applied. So first of all, there is 2 hyperparameters. There are only 2 hyperparameters in. Okay. Anybody wants to take any attempt? What is the difference between parameter and hyperparameter? Anybody? What is the difference between parameter and hyperparameter? Anybody? Okay.
No,
so you want to tell any attempt? So okay,
No
I
idea.
will tell you what it is. Yeah, you come here. My slide is visible? My slide is
Yes, sir.
visible?
Yes, sir.
Okay, now our basic model equation was logit. Logit means log of odds. I explained you yesterday. Log of odds is nothing equal to beta 0, beta 1 x1, beta 2 x2 up to beta k xk. Okay. So what are model parameters in this? Anybody wants to take any attempt? What are model parameters in this? What are model parameters? They are in front of you. Tell me. Yes, and madam, if I covered theory, one hour theory yesterday, and if you are not able to tell model parameters, then it will be taken as my failure only, not your failure.
Beta 0, beta 1, beta 2, and beta k.
Yeah. So beta 0, beta 1, beta 2 up to beta k are model parameters, right? Once we know the value of beta 1, beta 0, x1, beta 1, beta 0, beta 1, beta 2 up to beta k, means our model is clear. We know the model. Then put any value of x1, x2, any combination of x1, x2 up to sk, we get the probability, right? So equation is defined by beta 0, beta 1, beta 2, and beta k. Agreed?
Yes, sir. Agreed.
So without that, you cannot have your equation. So these are very basic parameters to define our logistic regression equation. So these values are called parameters. They are model parameters. They are model parameters. But some things, two of these things which I am showing you here, penalty and C. Penalty and C. These two are not there in the model. But when you apply L1 regularization or L2 regularization, it also becomes a part of model only. I'll show you in the end of the class. So when you apply L1 regularization and L2 regularization, it becomes the part of model itself. So these are the parameters. If I choose either L1 or L2, it varies my beta 1, beta 2 drastically. If I choose either L1 or L2, my beta 0 and beta 1 and beta 2 change drastically. If I choose C equal to 1, 10, 100, 1000, whatever, my beta 1, beta 2, beta 3 change, my beta 1, beta 2, beta 3 change drastically. Means a small a choice. If I choose L1 or L2 as a regularization, my beta coefficient will change, and then I will change the penalty value, either C. That also will change my beta coefficient. So these are they are called these kind of hyperparameters. These kind of parameters which are not there in the model, which are not there in the regular model, but they still affect, their choice still affects our choice of their choice still affects our beta coefficients. So such things we call as hyperparameters. Understood? Anybody wants to explain in their own words?
So basically, in that example, when you specified C is equal to 110, 100, 20,000,
Yeah.
So you iterate that parameter, that loop, that fitting model, and getting the estimates for one time. Every
No.
time you run
C1, one combination will give you one set of beta coefficients.
correct.
L1,
And for
L1 and 1. L1 and 1 will give you one set of beta coefficient. L1 and 10 will give you another set. L1 with 100 will give you another set. L1 with 1000 will give you another set. So these are 4 models. For L1 itself, we are going to get 4 models.
No, it's 8 models, right?
Yeah. I'm just talking about L1.
Okay, it will be 4 models, correct?
Yeah, for L1 there will be 4 models, and another 4 models for L2.
Correct.
Understood?
Yeah,
So total 8 models. So total 4 values of C and these 2 values. So I can make it why I am taking it to 10,000. I can add over 2-3 more. No, I take 50,000. I can take 15,000, 1,500. I can take 2,000. I can take a couple of more. So that now in this case, how many total models will be there? I have taken 5 values of
12.
12 will be there, right? 6 is 12, right? So like that means a hyperparameter means if we slightly tweak these hyperparameters, my model drastically changes. These are hyperparameters. That's why we call them hyper. I slightly tweak my hyperparameter, my model drastically changes. Handle is a kind of handle. Matlab, what is the most important part in bus or scooter? For a driver, it is handle only. Whatever direction I will turn, it will turn. And what is our model? Model is engine, body, and all are our models. But what is hyperparameter? Handle. Handle and accelerator. Accelerator I will give, speed will increase. And if I just turn it, direction will change. So handle and accelerator both can be termed as hyperparameter of the scooter. Rest all parts can be termed as parameters, modular parameters. Is this understood now? Understood? Is this understood?
These are parameters which are not part of the data, but external parameters which can be used to fine tune.
Yeah, which we introduce externally to the model.
To fine tune the model. Is that
to fine tune the model? Exactly, madam. Exactly. Yeah, exactly. You defined it right. To fine tune the model. So now you remember now we did so many repetitions with value of C, right? One time we took C equal to 10.01 and all we took, right? So you need not do it manually, just specify one time. Here you specify 0.01, you specify at here you specify 0.001, 0.01, 1, 10, once for all you specify. So what is the advantages of if I take more value of C? What is the disadvantage? Can anybody tell? If I go on adding value of C,
more computation time.
More computation time, because that many more models I will be creating. So with this 0.01 and all, this 4 and 6, I add one more 0.005 in between. 0.05. Okay. So I add like that. Now, not here, it will come here above 0.01. So it will come here. Okay. So there are 3 and 4, 7. 7 into 2, 14 models will run instead of 1. So that is the disadvantage. So you have to choose your variables very, very judiciously so that your computation time in deep learning, if you go this kind of variations in deep learning, then your deep learning model will run forever. One deep learning run takes half an hour to 45 minutes. And if you want to run 14 deep learning models, it will take 3-4 days, right? In between light will go, your computer will disconnect, or many things will happen. So deep learning and all, there are different method of parameter optimization. So that we'll have a look. Okay, so it is understood. So once we give the parameters like this, we give the parameters, then there is a method called grid search CV. Estimator means we are giving logistic regression is our estimator. Parameter grid we have to give what we have specified here as parameters. Scoring. So based on what we have to do the evaluation. So here we are doing scoring based on accuracy. Why? Why we are using accuracy here? Why not other thing? Can anybody tell why we are using accuracy here? Anybody
Because
wants to
we
take?
want to know the correct percentage of how much.
No. Why we first at the first place? Why I am putting accuracy and why I am not putting precision here? Just tell me. I could have put precision also. Why I am taking accuracy here? Tell me. Why I have made a choice? I have made a choice because my classes, the classes, 0 class and 1 class, they are fairly balanced. Say 60-40, 50-50, 50-30, 60-30, 70-30, like that, they are fairly okay. If my, yesterday I explained to you, if my yes positive class is very less, say less than 0.1%, I cannot use accuracy. In that case, I will give very simple measure, RUC, AUC, ROC.
But Shailendra sir, in case of our sample data is totally imbalanced, then we don't do upscaling or upsampling or downsampling.
We do it. Yeah, we do it. But still, in
Then,
such a case, we always better. In any case, you give only ROC AUC. Whether it is balanced, whether it is unbalanced, whatever, is a safe measure to have. Accuracy is always dicey. So always have ROC AUC.
okay. So you mean to say when the data is basically fairly balanced in a case of
Then only we use
go for
accuracy.
accuracy.
Yeah.
Otherwise, it's always better to go with the blind default option of ROC AUC.
If you are in a doubt, just go for ROC AUC.
ROC AUC.
Because it is always good to have. Accuracy. And another is, I will put here RSA AUC. Use. And I don't know whether it is in caps or smalls. So it will be as if accuracy is in small, it should be also in small. So ROC AUC. You cannot give caps. If it takes small values, you cannot give in caps. So I suppose accuracy is if it is in small letters, so ROC AUC also should be given in small only. CV equal to 5 means run 5 times. So now can anybody tell me this with this parameter grid, this and CV equal to 5 total, how many models will be made? Can anybody tell me? I want to attempt, Ashwini madam, you tell me. I have this parameter set. Hope you are not sleeping, Ashwini madam.
Yes, sir. I'm.
And you tell me with this 5, this CV equal to 5 and this parameter grid, how many models total, how many models will be made?
Sir, 13.
No. How 13?
So because that was 12 and it is only 1, so that's why
No,
I said.
I change. You count once again. Parameter grid is more than 12. Count. Okay. So anybody from seniors? Senior, how many models will be made?
Sir,
So it's
frankly
14
speaking, I don't know. 14 into 5, is it?
Yeah, exactly. 14 into 5.
So CV, what does it indicate, sir?
Means with all this, with one model, you have to run with 5 times. One combination it will take.
Okay.
L1 and 0.01, suppose. One combination it will take, and for that it will make 5 models. And it will give you the average.
No, sir. I think it will create 7 into 2, 14 models. For each model, it will run it for 5 times and take the
Same thing I am
average.
telling, boss. Same thing I am telling.
Yeah, correct. Yeah. So 14
model it will create first of all, right? And each model it will run 5 times.
5 times, correct. So
same thing I am telling, na?
Total runs, yeah.
So total, how Ashwini madam see 2 here, L1, L2, these 2 choices. Then 7 here.
Yes, sir.
7
Yes,
into 2, 14.
Yes,
and for
sir.
each of the 14 model, it will run 5 times. So 14 into 5. Can anybody tell me 14 into 5 without loading a calculator? How many models?
70.
70. Yeah, nice, madam. You have nice arithmetic. So you must be a good student in your college life.
Maybe, sir.
Okay. So nice. So we have good students here. So 70 and so 70 models will run. So it needs really a good machine. And your data set also is very huge. Huh? You know, you have 1,42,000 rows. You remember that also. So it really needs a good machine. So I think your machine, if you run this, I don't think it will run anything less than 45 minutes. It will take this code. Okay. So that's why for deep learning, compulsorily I will suggest everybody to take Google Colab Pro. Otherwise, your deep learning will never run. All students, all seniors have to take Google Colab Pro. You have to swipe your credit card on with Google, spend 870 rupees per month, and take the basic subscription of Google Colab Pro for learning deep learning models. Otherwise, you will not be able to keep pace with the classes of deep learning. So almost for students, I am specifically telling you, if you want, you can group 2, 3, 2, 3. You can group up and take up one model, one subscription, because 24 hours nobody will run. One guy can run in the morning, one can evening, and one can run in the night. So like 24 hours you can use it. There is no limit on a number of hours usage. So students can take combined 2 and 3, and they can take 1. Okay. So kind of you assume that for learning deep learning, it is for coming in deep learning classes, this Google Colab Pro will be kind of compulsory for everybody. I am not making compulsory because I am not making any money, but if you want to learn it, you need it. That's a basic requirement. Okay, so grid search once runs on train accuracy, it will run fit, it is running on training. Then we say we find base score is 0.84, and base penalty, base it will give you base penalty. See, just execute this code there, base score, base params. So base param it will take which base params and base estimator. So base params means we said penalty L1, and base score was run this base score grid search dot base score, it will give you base score. Then penalty base result are with this penalty L1 and C equal to 1, with C equal to 1, with C equal to 1 and penalty as L1, best results are coming. Okay, then test set it has run, test set score, just test accuracy is 0.85. So we are done. Result and conclusion, I think you can read when I share, and there are some nice references given if you want more. So I think it was a marathon kind of exercise today, very big code, and I gave you a lot of things as homework. Otherwise, you dinner also you have to take on table only. So a lot of things I have given exercise for you students. You have to do it at home if you want to keep pace with the deep learning and other concepts, because whatever concepts are given today, they are used throughout deep learning and all the machine learning, deep learning. These concepts will be useful. Okay, it is not only for logistic regression. Throughout deep learning, they will be useful. So I suggest whatever homework I have given you, you make a PDF out of it and submit. Everybody submit me. Everybody has to submit me in the group compulsorily. Whatever questions I have given, you convert, you search Google, make a PDF and submit me. You take it as a requirement. Malini madam, have you noted down all the questions?
Yes, sir, I have.
So can you please write down in a word or statement and share with everybody?
Sure, sir. Sure.
Just write down in a word statement all the questions, share with everybody. And for all students, it is a requirement that you write the answers and submit as PDF. Take it as a homework. It's a college class only, okay? So you just submit as a PDF, you submit by next Saturday. Lot of time. You can complete in 1 or 2 hours, madam. Just submit it next Saturday. Okay.
I have included some more questions like what is hyperparameter, what is grid search.
Yeah, madam. You put everything, whatever you have included, you share everything.
Okay.
Okay. So I think this is all logistic regression, and confusion matrix onwards, everything grid search CV, confusion matrix, up and then this accuracy, precision, recall. They are very useful concept because across the models they will be used, whether it is deep learning or whether it is random forest or whether it is XGBoost or what is a decision tree. Across, whenever there is a classification type of problems, these metrics will be used. Same thing. Once you do prediction on test and train, same thing you go on passing in different things, you will get the matrix. Grid search CV also used everywhere. So like that it is. And only I am sorry today is that we have very few students took advantage of it. That's where I am a little bit sad. Anyway, that is not my problem. So with this we'll end, and if you are having any questions, please come up with that.